Hello and welcome to the channel where you get to laugh at me as I struggle to solve the Nerdles. Because I type in sums like that and I get hardly any information. Although having said that, obviously, ruling out all of those digits is actually quite a lot of information, so I shouldn't complain. Let's try 46 plus 44. I should not have tried so many 4s. But we've ruled out a 0 as well, so we've just got 9s, 1s and 6s. What on earth kind of sum can we do with that? 9 plus 1 plus 6 equals 16. Oh, very close. But we'll obviously get it right this time. So we've solved it in 4. Not too bad. A lot quicker than yesterday. So we move on to the Nerdle, and we start with the same sum. And we've got lots of information on that bottom one. That's very unusual. So 90 something. What do we think? It could be minus 50 equals 40, minus 80 equals something in the teens. Let's try 95 minus, no, it can't be minus 18, it'd have to be minus, or let's try minus 38. I'd rather avoid the duplicated 5s if I can help it, but it is what it is. Everything else is plausible and consistent, I think. So, this digit minus 8 equals this digit. Whatever digit we place here, we're not going to get a 3, a 5 or a 7 here, which means, well, sorry, whichever digit we place here out of 3, 5 and 7, we're not going to get a 3, 5 and 7 here, which means that one of those two must be the unknown digit, because we know 5 out of the 6 digits. So what can we do with that information? Let's try 93 minus something 8. So it would have to be minus 18 to get the 7 here. Equals 75? Oh, still not. Maybe I should look at the top one, but we really haven't got much information about that, so I'm going to stick with the bottom one, because I feel like it must be unique by now. Also, I did say that if we use 3, 5 and 7 in the second digit, we can't use 3, 5 and 7 in the last digit, and I've completely contradicted that. But I think it must be true now that we've ruled out everything else. Where can the 7 be? The 7 has to be here. It's the only place left, which means that the last digit is a 9. And then that has to be a 5 and that has to be a 3, because it can't be the other way around. So this has to be correct. And now we've got no information on the top one. We haven't used 4s or 6s. So, what are we thinking? 4 times 5 plus 6 equals 26, why not? No 4s or 6s, I was right not to use them. Oh. Two times 5 times 2, I think it has to be. Which equals 20. Oh, I've made a bit of a mountain out of a molehill there. 6 guesses is about as long as it ever takes. Not my finest, given that there wasn't even any difficult multiplication or division, unlike this one, which might take a while. So what are we thinking? 82. Well, okay, so if it's what's the units digit going to be? It's going to be a 2-digit number times 7, or a 1-digit number times a 2-digit number that ends in 7. Now 8 times 7 equals 56, so it could be an 8 here, and a 6 as the last digit, or it could be 6 times 7 equals 42 for the units digits. So what do we reckon? What is 98 times 7? That's is 672, which is sadly not quite correct. No, it's more than that anyway. 98 times 7 is 702. I was way off. 58 would be 350, 406, 68. No, it can't be 68 because we need the 6 at the end, so that can't be right. What if it's 8 times something? 8 times 97 would be 700 and something. 57, 27 is not going to be big enough. 57 is going to start with a 4, so no, none of those can be correct. So it has to be something 6 with a 2 at the end. I'm fairly sure that bit is correct. The 6 might be 1 to the left. So 56 times 7 equals 392. 86 times 7 equals 602. Okay, let's go back to being 6 times something. 6 times 87. No, 6 times 97. Does that equal 582? I think it does. 2 1/4 minutes. I think that was quite a difficult one, but I also think I could have solved it quicker with a little bit of luck and trying to, well, obviously if I'd tried things in the correct order quicker. Right, how quickly can we do this? How about 102 minus 4 equals 98? No. So that has to be a plus, surely, in order to get big enough so that when you take away 4, you get a 2-digit number. Could be 12. I think it has to be 12 because I don't think we can use the 2 at the start. We won't be large enough. So 8 plus 8. Yes, in 44 seconds. Not too shabby. We'll finish off hopefully quite quickly with the minis. Let's do something different. 14 minus 6. That's slightly different to what I normally do, and I really shouldn't have bothered. What do we want to do? I wanted to do some division, but 42 over 6 doesn't work. 48 doesn't work. I don't want to do 49 over 7. It duplicates the 7s. 20 over 4. That uses all new digits. So it is division. It's probably just going to be 45 over 5. I should have just used repeated digits earlier, as it turns out. I don't think it was unique at that stage though, so I got a little bit lucky to get it in 3. Let's see what happens with this. In fact, today, let's try 4 times 3. Let's change the sum slightly. Oh, equals 12. Okay, so that bit's correct. Let's just try, I was going to try 13 minus 7, but it could be minus 8, minus 6, or minus 5 for the bottom one. And it doesn't have to be 13 in the first place. What do we think for that top one? Let's try 7 plus 5, because it will give us information on the bottom one as well. Oh, well, it turns out that it's correct. Okay, so let's try 13 minus 8 then. That was correct as well. That definitely wasn't unique. It could have been 13 minus 5 for a start. But yeah, solved it in 3 again for the mini Nerdle, which is, as I keep saying, about as quickly as you can do it. Pretty happy with that. Thank you for watching. Bye for today.